Hello everyone, this is my presentation video for my final year project part 1 or project Sarjana Muda part 1. The title for my research is Detection of Advanced Persistent Threat Using Machine Learning and Correlation Analysis. My name is Hugh Ji Sun. My supervisor is Dr. Anazida Binti Zainab. The presentation will be structured into 9 sections: problem background, problem statements, proposed solution, aims, objective, scope, contribution, methodology, and lastly, the design of the research. Now, problem background. First of all, what is APT or Advanced Persistent Threat? APT is a sophisticated, sustained cyber attack in which an intruder establishes an undetected presence in a network in order to steal sensitive data over a prolonged period of time. In simple words, you can also understand APT with its first letter of each words, advanced, meaning that the attacker uses sophisticated tools, advanced technology to conduct the cyber attack. Persistent, once the attacker has breached the system, the attacker remains hidden in the system for a long time, or it also means that the attacker has been paying continuous effort in breaching the system. That's what persistent means. And threat is anything that can exploit a vulnerability intentionally or accidentally that destroy an assets, digital assets. And what is the goal of APT? It's normally espionage or data exfiltration, or it can be both, meaning that the goal of APT is to spy on the target, the victim, and exfiltrate or steal the data from it. Now, what are the characteristics of APT? APT has its own attack sequence or attack cycles, meaning there are steps when it comes to APT, step 1 to steps number. Then it's also low and slow network characteristics. So when the attacker is in the system network, it has a low and slow network characteristics that is difficult to detect by normal intrusion detection system. And thirdly, APT is normally financially sponsored by people that they hire this group of expert hackers to conduct this attack. Some of the example of APT attack and group is GhostNet, Stuxnet, Deependa, and etc. APT. Now, cyber kill chain, as I've mentioned earlier, that APT has its own attack sequence steps, and the steps of APT can be expressed or understood with cyber kill chain, or also known as intrusion kill chain. So the first step of APT is reconnaissance, where they collect data of the victim, information that they can use to weaponize their attack, and then they deliver the payload to the victim system, and then it exploit the system successfully, then it install the malware or the backdoor in the victim's environment, and then they command and control the victims remotely, and lastly they act on the objective which I mentioned earlier, is either to spy on the victim or to steal the data from it. Now, why is this important? Is that we need, in order to detect APT or to prevent APT from destroying the assets or to achieve its objective, we need to break the chain. We need to break the attack chain of APT. For example, if we detect delivery stages of APT into the system, and we manage to stop it, then the rest of the stages not happens. Or if we able to stop as early as the reconnaissance stage, the rest of the attack can be prevented. So is one of the important things in detecting APT is to stop uh, the attack before it happens. So now we go into existing work. What are the research methods, what are the detection methods that uh, others researcher has done? So this is a model, APT detection model based on unknown domain. So basically, what this model does is it scans through the networks and find unknown domain or domain that uh, the traffic has never visited before. So you can see that they check on the DNS log, the network traffic, and the unknown domain monitoring. But but the problem is, as I've mentioned earlier, uh, APT is a multi-stage attack, and in order to effectively detect APT, we need to uh, discover the multi-stage of APT. So what this researcher does is he only focus on one stage of APT, which is command and control, where they visit unknown domain. And so this solution is susceptible to single point of failure, where if they fail to detect the unknown domain, the rest of the stages of APT will remain unknown to them. The second existing work is by Garfield in 2018, where he uses many different detection modules uh, being deployed in different parts of the system. And these small modules have its own function in detecting the different uh, stages of APT. For example, Tor CD means it detects the data exfiltration of the APT and others as well. So these alerts, once they detect the, the stages of APT or any attacks that APT stages use, they'll create an alert, and the alert will go to a correlation framework to correlate the alerts, as I mentioned earlier, multi-stages of APT. Then they correlate the different alerts to make sure that it's APT that they're detecting and not just any other traditional attacks where attackers have just normally just attack and they leave the system, and then they put the results into a prediction module. But the weakness for this solution is that you only detect certain attacks, as I mentioned here, these modules. So what they're capable of is defined by what these modules can do for them. And these modules require constant update in order to detect the latest APT. Thirdly, you have detection based on malicious DNS and traffic analysis. So this is very similar to the first one, where unknown domain. So the weakness for this is that it's domain independent. So if the malware, when it connects to the command and control server outside to the hackers, uh, if it's domain independent, it fails to detect uh, the stages, because some malware they use a hard-coded IP address for the servers that they want to connect, but these solutions fails when hacker uses dynamic IP address. So in conclusion, uh, we can conclude that most of the current APT detection solutions that experience single point of failure, not able to detect multi-stages characteristics of APT, and most of the current APT detection systems are not able to correlate APT stages. Proposed solution. So to overcome this problem, the study proposed that we build a detection system that is able to detect all APT stages identifiable through network traffic, delivery, command and control, and exfiltration. So these three APT stages will be the main stages that we want to detect in this study. And secondly, to overcome this problem of correlating the stages, we're going to build a correlation module that can correlate the results and construct the APT timeline, attack timelines. The aims of the research is to develop an attack system using Adaptive Neural Fuzzy Inference System, or ANFIS, that detect APT stages from network traffic and a rule-based correlation module that correlate APT stages. So some of the research questions that is designed to help us with the research is to how to create a detection system that can detect multiple APT stages, what are the techniques that can correlate the detection alerts, how to evaluate the accuracy of the detection results, and how to design a detection system with high true positive rate and low false positive rate. Now the three objectives for this research study is to develop threat detection module based on cyber kill chain, as I've mentioned earlier, using ANFIS. Second objective is to develop APT stages correlation module to reconstruct the APT attack timeline. Thirdly is to test and analyze the accuracy of the detection system. The scope of the research is that we'll be using Garfield's dataset. We'll build the system in Python. It will based on 7 stages of cyber kill chain and only include the 3 stages of APT that can be detected through network traffic. So this is an example of Garfield's dataset. You have the alert type from the modules, you have the timestamp, and we have the source IP, source port, destination IP, destination port, infected host, and the steps. The contribution of this research is that an APT dataset labeled with APT stages will be produced. We'll generate our own dataset using Garfield's dataset, APT detection framework using ANFIS, detection frameworks that classify APT into its stages. As I mentioned earlier, most of the current detection, they do not detect multi-stages, but they focus on one stages of APT. Then the fourth contribution is a correlation module that can correlate APT stages. So this is the overview of the proposed solution. We have APT detection module, the first part, and then we have the second part, the correlation module. So we start with the label traffic data, feed into ANFIS, Adaptive Neural Fuzzy Inference System, as a classifier to classify this data into delivery, command and control, exfiltration, or non-APT. So we'll be training our ANFIS to do classification, and then once the data has been classified into these 4 stages, the result is feed to this correlation module to correlate the traffic that has been labeled into its own attack timeline based on its timestamp and infected host. There are 3 phases for this design. Firstly is to develop the ANFIS. Secondly is to develop the correlation module. And lastly is to test the performance. So in order to develop, we first need to understand what is ANFIS, or what is Adaptive Neural Fuzzy Inference System. So it's the combination of neural network, the technology of neural network, with fuzzy inference system. Fuzzy inference system has a few elements. We have the fuzzification, defuzzification, we have the knowledge base, which have database and rule base, and the decision making units. So crisp value will be the input, then we fuzzify and make decisions based on database and rule base, and then defuzzifies and get the crisp value once again. So what is fuzzy logic actually? In normal crisp value, you have 1 and 0. When we do classification, we have 0 or 1, yes or no. So what fuzzy logic does is instead of classifying them into 0 or 1, uh, this or that, it gives the membership function value for the input. So for example, if the quiz value is 2 or the service is 2, then the specified value based on this function is that is 0.5 poor rating, poor service, or 0.1 good, or exactly 0 for being excellence. If the quiz value is 5 services, if 1 for being good and 0 for being poor and excellent. So we can say that if the service is 5, it's good. If the service is 2, if there's only 2 service, is 0.5 poor and 0.1 good. And then we also have the fuzzy if then rule. So if the service is excellent, then the rating is high. So with this understanding of fuzzy logic, we have this. So this is what fuzzy inference system does. We have many member function. We have so there's 2 input feature here, accuracy and time. And this is the fuzzification part. This is the decision making unit, inference, and this composition is where they combine the different membership function that's been membership value that has been generated, and they combine it into one value, max mean integration, which is the defuzzification part. So this is a fuzzification, this is the decision making with the if then rules, and this is the defuzzification part, and we get the crisp value once again. This is the architecture of UNFIS. This is basically the same as the previous slide. This is exactly the same as this. This is the fuzzification layer. There's 5 layers as you can see, just like neural network. Layered. This is first layer, fuzzification. Second layer, rules layer, normalization layer, defuzzification layer, and then we have the output. The results of phase 1 is that there will be a train UNFIS with learn membership function in fuzzy if then rules. Secondly, the traffic data will be labeled with its classified APT stages. So the neural network part is that this fuzzification layer and defuzzification layer, we call this the antecedent parameters, and this is the consequence parameters. These 2 parameters, layer 1 and layer 4, is what neural network will learn. And phase 2, we have the development of correlation module. So if we will be using rule base, so rule base is if A equal to B, B equal to C, then A equal to C. And the line graph is used to visualize the APT stages. We will have the timeline here, we have the APT here, then you will be seeing 3 dots. First dot is the delivery, second dot is command and control, and third dot is the data exfiltration. The third phase will be the testing on UNFIS. We'll be having the confusion matrix, true positive, false positive. We have the table, then we'll calculate the F1 score and also the AUC ROC curve. F1 score is the harmonic means of precision and recall. It's used to test the accuracy, the test accuracy of the system. And AUC ROC curve is to measure the ability of the trained model to classify 2 classes. So the design of the research will have three phases. So the first one, development of ARM-FIS. First, we need to prepare the data. As mentioned earlier, we'll generate our own data together with Garfield's data set. Because Garfield's data set only contains the malicious traffic of APT, and so we need to insert and generate our own normal traffic using the noisy program, as you can see here. Then we use Wireshark to capture the generated traffic, and then we export the traffic data out from Wireshark, and this is how it looks like. Source IP, source port, destination IP, destination port. So this is exactly the same features as Garfield's dataset. Once the data is ready, we'll do feature selection. Three methods will be used, and this is the example of correlation heat map. The fuzzy if rules and membership function will be generated using the subtractive clustering method to generate the initial membership function. So there will be an initial membership function for each of the features selected here, these few features, and then the number of fuzzy if then rules is all possible combinations of the input features. And there are 6 types of membership function, and we don't know what is the best membership function types to use, but we'll try out a few of the membership function here. And for the training of ARM-FIS, you start with 50 training iterations until the constant error reach. So you can see that as the number of iterations increases, the training error also decreases. Phase 2, development of correlation module. We'll filter out alerts with similar attributes. For example, we have 2 traffic being labeled as stage 1, but these 2 traffics have same source IP, destination IP, and same features, so it will be filtered out the redundant traffic. Then we'll correlate the different stages. If step 2, the infected host is same as step 1 and infected host of step 1, means they are the same APT scenario, and also the same for step 3, step 2, step 3, and step 1. If they are the same host and same destination host, means they are related, and we only visualize APT stages that has more than correlation index of more than 0. If they have less than if they are 0, means they are not related, so we will not visualize them. And the third part is the testing. As I mentioned, we'll compare the true positive rate and false positive rate with Garfield's ML APT. This is the model proposed by Garfield's. You compare our result with his results. And for future works, what I will be doing in PSM2 is to pre-process the data, as I've mentioned, generate the membership function, initial membership function. We'll do the training and the testing of the model, ARM-FIS, develop the correlation model based on the design, as I've mentioned earlier, and then we visualize the timeline, and lastly we measure the performance with F1 score and AUC ROC curve. That's all for my presentation. Thank you.